Hello everyone, welcome to another episode of this series. And I've been doing easy questions these days, so I want to step up a bit and do a hard question, right? So here, this is one question from A level. I found it online and I want to try it. So yeah, let's do this. Number 8. A rough slope is inclined at an angle of 25 degrees to the horizontal, so like this, 25 degrees. A box of weight 20 newtons, so the weight is 20 newtons, is on the slope. A rope is attached to the box and it's parallel to the slope. The tension in the rope is of magnitude d newtons, so it's the tension right here. And the diagram shows the slope, the box, and the rope. Okay, so this is the diagram right here. Alright, so what is it asking? A box is held in equilibrium by the rope. Number 1, show that the normal reaction force within the force and the slope is 72.5 newtons, correct to the 3 significant figures. So let's draw the forces here, right? So this is the tension force holding at the box. And this is the acceleration, the force done by gravity. And then this is weight force right here, and this is the normal force right here. Okay, so we know that the weight is 80 newton. Okay, and this is the same as T here. I just say T prime, right? And then this is normal force, right? Okay, so we can actually resolve this wave factor like this. We can resolve the vector like this, 90 degree angle. And then what we have right now is I'll draw you guys a triangle here. So this triangle right here, okay, that's a triangle. This is 180 degrees, remember that? Right, and then, well, technically it's not shown in this kind of drawing, but I can draw it right here. This is the slope, the box is right here, and the weight is like this, and this creates and this creates another triangle here, and this is 25 degrees. This is 25 degrees, so this must be 25 degrees also, right? Because this is a 90 degree, this is 90 degrees, right? This is 90 degrees to the angle, and this must be 25 degrees, so this must be 25 plus 90 minus 180, and this must be 25 degrees also, so that's gonna be the key to this. So we can say that this is 25. I hope I explained it well. I didn't really explain it well. And then 25 degrees, this is 80, right? So yes, it's gonna be like this, and I have to show that the reaction, the normal force is 72.5 newtons, right? So we can actually do a normal trigonometry. So the normal force is here, so this vector right here must be the same as the normal force. So I just need to use trigonometry to find that. So let's name this n prime. So n prime is going to be about 80 multiplied by the cosine 25, and this will get 72.5 newton. And since n and n prime are the same, that means that the normal force right here, right here should be 72.5 newton, right? So this shows that the normal force is 72.5 newtons. Let's go to number B. The rope is now released and the box slides down the slope. Find the acceleration of the box. Okay? So define the acceleration of the box. So we can, let's see here, how can we find acceleration? We can use the formula F equals to ma. We can find the force using this triangle. right? We can find the volt, and we can find the mass because the weight is given. So we can actually do this, right? So to calculate the force, we have to go look at this triangle again. So with the weight here, we have to resolve the factor like this, right? And then what we have is, I won't add arrow because it's kind of in my way, right? So it's CW, this is gonna be 25, right? And then what's gonna be is, this is gonna be normal force, and it's gonna be the force, right? This the only force that is making this box slide down is this force from the wave vector. So that's why I say that this is done by for gravity. Yes, because gravity is tilted at an angle, so it can be resolved into two vectors. And the y vector, or the normal force, and prime vector in this case, directly cancels out with the normal vector. But this vector, let's name this f vector. This f vector is pointing this way. Okay, the f vector is pointing this way, which is the same as this force. And this is t prime, and t prime is the same as t, so that will be the tension of the rope. So we can actually find the tension of the rope here. So let's see here. So we can go to find f, and this is just easy, right? W is 80, and we use trigonometry to find this. 80 sine 25, and then this will get 80 sine 25 about like 33.8 newtons. No, force this way, so it'll be 33.5 newtons this way. No, not 8, no, not 5, it's 8. 8 newtons, right? So we have the force. Now we have to find the mass, which we can find easily. W equals G weighs 80, so it will be mass equal to 80. Right, divided by 9.81, and then that will get about 8.1, let's say 8.96 kilogram. And then now we just use the Newton's second law. F equals to ma, acceleration equals force over mass. So force is gonna be 33.8. and then the mass is gonna be 8.16, and then this will get, wait a second, 30.8 over 8.16, and that will get about 4.14 meter per second square. So that will be the acceleration of the box when the rope is no longer there, that the rope is released. We found the mass of the box. We found the normal force. We found the tension force. We also found the disc. Or how do you call this? How do you call that box? Force. To be honest, I know. Well, my English is really bad, as you can see. Right. So yes, this will be the end of today's question, and I excluded some questions because I am still learning, right? I am still at IGCSE O level, and I'm doing ahead and doing A level. That's why I'm not some theories and stuff I still don't know, that I'm still learning every day and trying to improve. So that's why I excluded some questions I don't really understand, right? So I'll try to understand that later. And then yeah, this is gonna be the end of today's video. I'll see you guys tomorrow. Goodbye.